All right, everybody. So this is chapter 8, lecture 2. For those following along on your handouts or whatever, we are starting at 8-8, which is studying and encoding memories. I'm going to go ahead and share my screen really quick. 1 second. Awesome. And I'll put this in presenter mode. Okay, so what are the levels of processing and how do they affect encoding? So verbal information is processed at different levels, which affects long-term retention. We have shallow processing, right, which is encoding on a very basic level. This is words, letters, or a more intermediate level, which is words, sound. So you're just hearing, right? That's shallow processing. Deep processing encodes semantically, right? Based on the word's meaning, right? You're attaching meaning to the words that you're hearing. The deeper or more meaningful the processing, the better the retention. So if you understand it, right, you are like what it means, you're going to remember it. That's why it's really important to when you're reading things, if you see a word that you don't know, look up the definition, right? Because it can help you remember it, as opposed to just remembering the word itself or remembering the sounds of the word. Attaching meaning to it will help you remember it. New information is processed easily when it is meaningful or related to your experience. Again, making up your own examples attaches meaning that's directly related to you, to the concepts you are learning. Ebbinghaus estimated that learning meaningful material required 1/10 of the effort compared to learning nonsense material, right? So we have especially good recall for information we can relate to ourselves, and a tendency referred to as self-reference effect. So when you can come up with examples and you can make meaning out of content you're learning and attach it to you directly, you are more likely to recall it, and it's easier for you to learn it. The amount of information remembered depends both on the time spent learning it and on your making it meaningful for deep processing. So what's the capacity for long-term memory? Are our long-term memories processed and stored in specific locations? So our capacity for storing long-term memories is essentially limitless. It's contrary to the belief that the more we fill in, we have to discard, right? So people previously thought if you put more information, more knowledge in, you forget or discard old information. And that's not the case. We are limitless in our ability to form long-term memories. So our information is not stored in a single location. There are precise locations within the brain, like across the brain, that help us form and retrieve memories, but there's not one specific location that is responsible for memories. Memories are brain-based, but the brain distributes components of memory across a network of locations, and it depends on the kind of memory as to where it will go in the brain. Some of the brain cells that fired when we experience something fire again when we recall it. Particularly things that have an emotional charge, right, might really trigger the amygdala if we are remembering a memory that caused us a lot of fear or sadness or happiness, right? That super emotionally charged memory. So despite the brain's vast storage capacity, we do not store information as libraries store their books in single precise locations. Instead, brain networks encode, store, and retrieve information that forms our complex memories. So what are the roles of the frontal lobes and the hippocampus in memory processing? So we have two conscious memory systems. So conscious meaning like we think of. We have semantic memory. So this is explicit memories of facts and general knowledge. This is the content you're learning in this course, in your other classes, right? General information, that is a semantic memory. An episodic memory is explicit memories of personally experienced events, right? Family holidays, school dances, right? And graduations, right? Things that you experienced and you have a memory of. So the hippocampus is the neural center located in the limbic system. It registers and temporarily holds elements of explicit memories before moving them to other brain regions for long-term storage. Neural storage of long-term memories is called memory consolidation. Go to our next one. Yeah. So this is an image of the brain, and highlighted is the hippocampus, right? Explicit memories are for facts, and episodes are processed in the hippocampus, right? That internal part of the brain that's highlighted in orange. And from there, it is fed to those other regions. So explicit memories, remember, are the facts and the episodes, the semantic and the episodic memories. Start here, and then they get moved out to different areas in the brain. So what are the roles of the cerebellum and the basal ganglia in memory processing? So the cerebellum, it's at the back of your brain. It's the very base of your skull, plays an important role in forming and storing implicit memories created by classical conditioning. Remember, those are the things, the memories you don't have to think of. They're automatic, unconscious, things like driving, learning how to build a toy, the procedures of your job. The cerebellum helps with those, along with the basal ganglia. It's a deep brain structures involved in motor movement, facilitate formation of our procedural memory for skills. So the skills that we learn, we can think the basal ganglia and the cerebellum. Another concept that is going to be really important for you to remember is infantile amnesia. So conscious memory of the first 3 years of life is blank. And that is because we do not have a command of language, and we don't have a hippocampus that is well developed. And those are needed to start forming those conscious memories. And the hippocampus, unfortunately, is one of the last brain structures to mature fully. So it's why we really don't start having memories, conscious memories, until we're about 3 years old. So how do emotions affect our memory processing? Excitement or stress triggers hormone production and provokes the amygdala, which is 2 limbic system and emotion processing clusters. So it provokes the amygdala to engage in memory. Emotions often persist with or without conscious awareness. Emotional arousal causes an outpouring of stress hormones, which leads to activity in the brain's memory forming areas. So you can have things like flashbulb memories, and these are clear memories of emotionally significant moments or events that occur via emotion-triggered hormonal changes and rehearsal, so remembering it or going through that encoding process. So an example, I have an example of a flashbulb memory. When I was in high school, I was riding with my friends to the mall in Nashville. So we were on the highway, and my friend was driving in the left lane, and they were going pretty fast. And beside us was an 18-wheeler. And my friend was going really fast. This 18-wheeler was matching our speed, so it was right beside us. And my friend did not see that at the end of the lane, there was this cement embankment sort of like thing blocking the lane. So they didn't see it. And when they finally recognized it, we really had 2 options. It was either hit this going like 85 miles an hour or try to get in front of the 18-wheeler. So my friend like hit the gas and got in front of it, and we were fine. We made it to the mall. But I have a very vivid flashbulb memory of us like driving past the 18-wheeler to get in front of it. And I can very clearly see the red and white, the white trailer and the red like truck bed, like an arm's length away from me as we are getting around it. And that was a really terrifying moment for me because I already have had a fear of driving in cars and the highway. So that is one of my flashbulb memories, caused by a fear, and the fear triggering that hormonal response, that stress hormones that made that memory really stick out, as a flashbulb memory for me. So let's go over again some of those brain structures and how they're used in memory. And we're going to be talking about the brain in more detail when we get to our biology and behavior chapter, but this is going to be really great, sort of introduction. So we have our frontal lobes, which is up here, frontal lobes. We have our basal ganglia, which is inside, sort of around this area of our brain. We have our hippocampus and our amygdala, which is really close to our brainstem, sort of in the center of our brain. And then we have the cerebellum, which is at the back of our skull, back part of our brain. So the frontal lobes and the hippocampus, this front part right here and this internal part right here, are responsible for those explicit memory formations. The cerebellum and the basal ganglia, which is these structures right here, are important for implicit memory formation, and the amygdala right here is responsible for emotion-related memory formation. So how do changes at the synapse level affect our memory processing? So long-term potentiation. Long-term potentiation is an increase in synapse firing potential after brief and rapid stimulation. So after LTP, the brain will not erase memories. It is believed to be the neural basis for learning and memory. So as we learn more things or intake more information, LTP happens. There are more connections at the synaptic level, and that is where we start forming those neural networks, which is sort of the basis for the learning and memory that we know today. Kandel and Schwartz in 1982 observed synaptic changes during learning in the neurons of the California sea slug, Ablesia, I think is how we pronounce it. Their research pinpointed changes in sea slug's neural connections with learning. More serotonin is released and cell efficiency is increased during phases of learning. So this is the sea slug, right? And Eric Kandel, the neuroscientist, studied this slug for 45 years. And this slug has increased our understanding of neural basis of learning and memory. And this is the example of like LTP happening. So we have electron microscope image A that shows one receptor site, which is this gray part right here, reaching toward this sending neuron that's sending out information. And this is before long-term potentiation. So as we go through long-term potentiation, right, which is that rapid firing, that rapid stimulation that happens as we're learning something, the receptor sites, these little gray spots right here, have doubled. That means that the receiving neuron, which is the gray one, has increased sensitivity for detecting the presence of that neurotransmitter molecules that may be released from this sending neuron, right? So this neuron, now that LTP has been happening, there's been continuous stimulation in the learning process, right? On the synaptic level, that we are seeing these increases in receptors. So this neuron is able to detect and grab that information from the sending neuron. So we have two memory systems, right? We have the automatic, which we've talked about, and the effortful, which we've also talked about. Automatic, remember, it happens automatically. It's similar to the automatic nervous system where our body sort of does what it does without us having to think about it, like breathing, moving our blood around our body, right? Things we do not have to think about because our body does it. Automatic memories work in the same sort of way. We do not have to think about them. These are implicit memories, right? Non-declarative. So we do not have to consciously pull them back. These are processed in the cerebellum, the back of the head, and the basal ganglia, an internal structure. So things like space, time, and frequency are automatic, right? So where you ate dinner last or yesterday, right, is an example of a space, time, frequency automatic process of an implicit memory. Motor and cognitive skills, such as riding a bike, driving a car, those are also implicit memories, they're automatic. And then we have classical conditioning, learned responses to stimuli happening around us. Like your reaction by going to a dentist's office, that is an automatic implicit memory that's happening. You don't have to think about it. We then have the effortful memory processes. These are explicit memories, right? Declarative, right? Facts, information. We have to do a conscious recall. So these are processed in the hippocampus and the frontal lobe, right? Hippocampus being that internal structure in the brain, and the frontal lobe being at the front of the brain. We have the semantic memories, right? Facts and general knowledge, the things that you're learning in this class and in this chapter. And then episodic memories, right? Personally experienced holidays or personally experienced events such as family holidays. How do external cues, internal emotions, and order of appearance influence memory retrieval? So memories are held in storage by a web of associations, right? It's not just this single memory floating around. It's connected in a web with other things. Retrieval cues serve as anchor points for pathways to memories suspended in this web. When you encode into memory the name of a person sitting next to you in class, you associate that name information with other bits of information about your surroundings, your mood, your seating position, and different things like how cold the room was, what the content you were learning, right? That person is now associated with all these other things. Best retrieval cues come from associations formed at the time a memory is encoded. So this is one really interesting thing that works on the retrieving encoded memories. And that's when you are encoding information, right? You're doing that rehearsal process. Chew a specific type of gum, like this gum you're only going to chew when you're studying for a specific class, right? It could be like a spearmint or Hubba Bubba, whatever you like. And then you chew that same gum, same type of gum when you're taking your test, that gum becomes a retrieval cue. So you tasting the gum helps you recall the information you were encoding when you were practicing and doing your rehearsal. So you can use retrieval cues to your benefit by being intentional on the things that you are doing or associating with the material you're learning, right? Studying, if you have an option, right? Studying in the same class you're taking tests in, right? Practicing on the same field you're going to be playing your game on, right? Those retrieval cues help you with recalling that memory. Priming. So priming is activation, often unconsciously, of a particular associations in memory. So this is an example of priming. After seeing or hearing rabbit, we are later more likely to spell the spoken word hare as H-A-R-E, because we were primed, right, to the word rabbit, or seeing a picture of a rabbit, we were primed to think of hare, like a hare, or a rabbit, H-A-R-E, instead of hair, like the hair on your head, H-A-I-R. Associations unconsciously activate related associations. So it's not something you can necessarily control, right? If you were exposed to something, it's going to alter and sort of pull up those associations that you have connected to that thing. And that's called priming. Context-dependent memory. This involves improved recall for specific information when context present at encoding and retrieval are the same, right? Cues and context specific to particular memory will be the most effective in helping recall. So creating specific cues, and specific context when you are encoding information that you know you're going to have to recall later. It's going to be really helpful. State-dependent memories. So emotions that accompany good or bad events become retrieval cues. So mood congruent memories. This is the tendency to recall experience that are consistent with your own current mood, whether it's good or bad. So if you are in a bad mood, you are going to maybe look at someone's face and you perceive them as glaring at you, and you're going to feel worse, right? Because your mood is pulling up information from all the other times you've been in a bad mood. And so it's going to perceive that person's face as being a glare. Whereas if you were in a good mood, you're pulling information right from your long-term memory that's associated with you being in a good mood. You might perceive that person's face looking at you as interest and then end up feeling better. We also have the serial position effect, and it's our tendency to recall best the last information we learned, which is called the recency effect, and the first information we learned, which is the primacy effect. So when you're in a lecture, you're more likely to remember the first thing that you talked about in that lecture and the last thing you talked about in that lecture. So it's really important when you're doing your rehearsal to think about what happened in the middle and really focus on rehearsing that, right? Because the recency and the primacy effect are sort of working against you with that middle chunk of information. So we've talked a lot about memory and how we create memories and how we recall them, but what about forgetting? And so we have a quote by William James that says, if we remember everything, we should on most occasions be as ill off if we remembered nothing. So it's surely a blessing that most of us can discard the clutter of useful or out of date information, but our sometimes unpredictable memory can be frustrating, right? Because it's not a perfect science, and some things can happen to us, like traumatic brain injuries that can happen in a variety of accidents that can cause things like amnesia. So anterograde amnesia is the inability to form new memories, right? So you can experience, you have all your previous memories, your long-term memories, you can experience new things, and you can put those new things in your short-term memory, but you no longer have the ability to put those short-term memories into your long-term memory. A really good movie example of this would be 50 First Dates with Drew Barrymore and Adam Sandler. She was in an accident and she was no longer able to remember anything after, right, the day that she had her accident. It's like she was reliving that same day because that's the last thing she remembers. So she had anterograde amnesia. She was no longer able to form new memories. Each day was new. Next, we have retrograde amnesia. So this is the inability to retrieve information from one's past. A good movie example about this, I just looked it up. One second. The Majestic. The Majestic is a good example of retrograde amnesia. It's about a movie director during the 1950s. Jim Carrey was the main actor during the 1950s, during the Red Scare, where he was accused of being a communist, and he got into an accident. He developed retrograde amnesia. He was no longer able to remember who he was, right? And so he ended up receiving, right, a new identity. I'm going to watch those two movies again to make sure they're appropriate, but if I think they're appropriate, I'm going to post an announcement in our course Canvas. And I might offer those as extra credit if you watch them and then write like a 2-paragraph essay about how it relates to our memory chapter. Because I think those are really good examples of anterograde and retrograde amnesia. So much of what we sense, right, we will never notice. And what we fail to encode, we will never remember, right? Age plays an important factor in encoding, and there's an encoding lag linked to age-related memory decline, right? Because if we don't encode it, we're not going to remember it. That's why it's difficult, not impossible, but difficult for people who are older to go back to school, because it takes them longer to encode information, causing them to potentially suffer in classes because they are unable, right, at the speed in which classes go, to encode the information and say do well on tests. So age, it can impact our encoding. And then attention, right? Failure to notice something means we failed to encode it, and that it contributes to memory failures, right? We didn't notice something, we didn't encode it, and so we have no memory of it. So this is just what I said. We cannot remember what we have not encoded. So something might come into our short-term memory, but if we don't rehearse it, we're going to forget it. So even after encoding something well, we sometimes later forget it. Now, this does not mean that it's gone from our long-term memory. It just means we can't pull it back, right? We can't pull it out. Our course of forgetting, right? The course of forgetting is initially very rapid, and then it kind of levels out. So you're not going to necessarily forget everything, but it's going to, from the time you stop rehearsing something and time you stop rehearsing something, you're going to have a really initial decline, and then you're going to have a sort of steady out baseline. Physical changes occur in the brain as memories forms. We can track these changes and do what is called a memory trace to see how memories have altered our brain. This is the forgetting curve that I was just talking about, Ebbinghaus's forgetting curve. And this is the percent of lists retained. Remember, he was remembering nonsense lists. And so the day he stopped rehearsing, he was at like 60% of being able to recall the list. After one day, he dropped from 60% to 30% because he stopped rehearsing. And then he dropped by day 3 to around 25%. And then he kind of leveled off after 30 days to around 20% memory. So just like failure to encode something can lead to forgetting, right? Because it was never stored in our long-term memory. Failure to retrieve things, right? Being unable to retrieve information will lead to it being forgotten. Does not necessarily mean it's not there, right? It just means we are no longer able to pull it forward. So if we cannot retrieve information, it will be forgotten. We also have interference. That this goes along with retrieval failure. Proactive interference, which is forward acting, means your prior learning will disrupt the recall of new information, right? You'll get it mixed up with what you previously learned. You also have retroactive interference, which occurs when learning new information will disrupt recalling older information. So mixing up what you previously learned with what you are currently or recently learned. We also have motivated forgetting. And this is a little interesting. So Sigmund Freud argued that we repress painful or unacceptable memories to protect our self-concept and to minimize anxiety. This has been proven to not really be the case. Today, researchers think repression rarely, if ever, occurs. Forgetting is more likely when the information is neutral or it's not emotional. And we often have intrusive memories of the same traumatic experience we would most like to forget, right? So generally, if you have an experience that's really traumatic, really painful, really upsetting, something you would really like to repress, you generally can't. And it will come back as an intrusive memory. Whereas information that does not have any emotion attached to it, you will much more easily forget. So when do we forget? So forgetting can occur at any stage in memory. And as we process in information, we filter it, we change it, and then we lose a lot of it. So we have our sensory memories, right? Our sensory memories will momentarily register things in very amazing detail. There's a lot of little bits of information happening at our sensory memory. We then go into working memory or short-term memory. And there's only a few things that are being noticed, right? And being encoded. It's not as detailed. There's not as many bits of information as our sensory memory. Then we go into our long-term memory. And this is what's being encoded from our short-term memory going into our long-term memory. And sometimes these items are changed, they're altered, or they're lost, right? They're not necessarily no longer a long-term memory, but we might not be able to pull them forward. And then from long-term memory goes into retrieval of long-term memory. And this depends on interference, right? That whether it's retroactive or proactive interference. It depends on the retrieval cues that are around at the time. It depends on the mood we have at the time, our motives for remembering information. Some things get retrieved from long-term memory and some things don't. So forgetting and memory construction errors. So how do misinformation, imagination, and source amnesia influence our memory construction? And how do we decide whether a memory is real or is false? So memory is not precise, and we don't just retrieve information, we reweave it, right? We put puzzle pieces back together to make and pull back our memories. So Elizabeth Loftus and Catherine Ketchum said, our memories are flexible and superimposable, a panoramic blackboard with an endless supply of chalk and erasers. So reconsolidation is a process in which previously stored memories are retrieved and they're potentially altered before being stored again, right? So this can be altered by receiving new information, right? Hearing someone else talk about the same experience, a number of things. When you pull back that stored memory, it can be altered before putting it back in. Make sure, yeah. A misinformation effect, when memory has been corrupted by misleading information, right? Bringing in new information that is not necessarily true. Even repeatedly imagining fake actions and events can create false memories, right? You can, if you could continuously lie to your parent about breaking a vase in the house, and you said your dog did it, right? After so many times of repeatedly imagining or saying the dog broke the vase, you might end up with a memory of the dog breaking the vase, even though it was you. Digitally altered photos can produce imagination inflation and memories of events that people have not, in fact, experienced. So you can see an altered picture, maybe of yourself as a young child, and a person or a couple people in that picture, and maybe someone's wearing a Santa hat. Imagination inflation can cause you to sort of create memories of some Christmas event that never happened with people who were never there. There's also memory construction and leading questions that can influence how you remember something. So for example, there's an image of an accident right here. So initially, right, we see that this, the front bumper and the hood of this person's car is a little messed up, but this car doesn't really seem to have any damage. And then when we're, say, trying to remember an accident happening in court, and the lawyer asks us, About how fast were the cars going when they smashed into each other? This is a leading question, right? The word smashed is going to influence how you reconstruct that memory of the accident. So when we hear the word smashed, this might be what we end up seeing in our head as a picture of the accident, our memory of it. And as we can see, there's like parts or oil leaking from the car. Both of the car's hoods are messed up. There's glass and stuff on the road. The windshield of this car is broken because someone asked a leading question of us that made us alter the memory that we had. There's also in memory construction errors, there's also source amnesia. This is also called source misattribution. This is attributing the wrong source to an event we have experienced, heard about, read about, or imagined. Source misattribution, along with the misinformation effect, is the heart of many false memories. They may seem real, feel real, sound real, but source misattribution along with misinformation can lead to the creation of false memories. Deja vu is that eerie sense that I have experienced this before. This is generally because cues from a different situation may have unconsciously triggered the retrieval of an earlier experience. So you're remembering something that has happened, not necessarily that you're experiencing the same thing again, but there are cues that are pulling that memory forward. False memories feel like real memories and can be persistent and are usually limited to the gist of an event, right? Your false memories are not going to have super clear details. And if they do, there's details that will change as that false memory is repeatedly brought back. False memories are often the result of faulty eyewitness testimony. There are a lot of eyewitness testimony is not very reliable because people will often create these false memories, not intentionally, right? It's happens because of misinformation, right? The imagination, where is it? Imagination inflation, leading questions. So eyewitness testimony, not super reliable. Memory construction helps explain why dating partners who fall in love often overestimate their first impression of each other. And then why people who are asked how they felt 10 years ago about certain social issues recall attitudes closer to their current views than the views they actually reported a decade earlier. So how reliable are young children's eyewitness descriptions? So we've talked about how eyewitness testimony is not super reliable, but what about with children? So Cece and Bruck have studied extensively the effect of suggestive interviewing techniques and how easily children's memories can be molded. In one study, 58% of preschoolers produced false memories about one or more unexperienced events. Children can often accurately recall events when non-leading questions are asked by a neutral person in words that the child can understand, and if they're asked soon after an event takes place. And this is ideally before children have talked to adults that are involved in whatever situation it is. So why are reports of repressed and recovered memories so hotly debated? So the debate between memory researchers and well-meaning therapists focuses on whether most memories from early childhood abuse are repressed and can be recovered during therapy using memory work. And these are techniques that involve guided imagery, leading questions, hypnosis, or dream analysis. So there's a lot of debate within this. And this kind of leads to the two tragedies of child abuse, right? There's one, when people don't believe abuse survivors, and two, when innocent people are falsely accused of abusing people. And so us finding a sensible middle ground is really important. So those committed to protecting abused children and those committed to protecting wrongly accused adults have agreed on a couple of things. Number one is that sexual abuse happens, injustice happens, forgetting happens, recovered memories are commonplace, but that doesn't necessarily mean that that the unconscious mind repressed them, right? People aren't generally repressing memories. You can recover memories though, if you just forgot something, but it's not because they were repressed. And then memories of things that happened before the age of 3 are unreliable, and really you don't have memories before the age of 3. Memories recovered under hypnosis or the influence of drugs are especially unreliable. And memories, whether they're real or false, can be emotionally upsetting. They can cause emotional or physical responses, whether they happened or not. So forgetting, memory construction errors and improving your memory, right? How can you use memory research findings to do better in this and other courses, right? So number one is rehearse repeatedly, right? Whether it's reading through like root memorization or asking yourself questions and testing yourself. Making the material meaningful, create your own examples, relate them to your own life. Activate retrieval cues. The gum trick really does work. If you chew a very specific type of gum when you're studying and then chew that same type of gum when you are taking a test, that can be used as a retrieval cue, or use the same pen, right? The same specific color pen, or I don't know, wear a specific perfume, right? Or a cologne. You can create retrieval cues that can be used to help you during a test. Use mnemonic devices, minimize interference, right? Really distinguish previously learned information from new information, right? Making sure those retroactive and proactive interferences aren't happening. Sleep more. Sleep encodes our memory, right? You study, go to sleep. That sleep time is encoding and making short-term memories long-term memories. So sleeping more, super important. Test your knowledge, right? Both to rehearse it and to find out what you don't already know yet. That is why we use Launchpad. And I've said this a couple times, but it takes into account testing effect, right? So it shows you what you know, right? And you're rehearsing what you know, and then it shows you what you don't know and helps you rehearse that as well. So that is the end of chapter 8. There are 2 chapter lectures posted. Again, there is an outline, a handout, and a words to know. It has a list of important words from this chapter. I'm actually going to be adding some more to that, but that's going to be important in helping you study for this specific chapter. As a reminder, let me check the schedule really quick. You will have an exam coming up. So let me check and see when that is. Exam 1, which is going to cover chapter 1, chapter 7, and chapter 8. It starts September 19th, so next Monday, and it ends September 23rd, which is next Friday. So you have 1 week until your first exam opens. So please review chapters 1, chapter 7, chapter 8. You have a whole week to do it, but it is timed, right? So you're not going to be able to necessarily go and look up every question. So make sure you're studying for this test. Take it when you have, when you're not distracted, you have plenty of time. If you have not done the syllabus scavenger hunt, I am not going to grade your exam. I'm going to put your exam grade in as a 0 until I see that you've done it. Most people have done it. I think I have 1 or 2 people who have not. So please make sure you've finished your syllabus scavenger hunt and you made a 100 or a 10 out of 10. You have your first paper due. That is going to be the Consumer of Psychological Science assignment. There is another video posted for that assignment. That is going to be due on Monday. I changed the due date. It's no longer due on the 16th. It's due on the 19th at 11:59. So that Monday that your exam opens. Monday your exam opens is the day you need to turn in your Consumer Psychological Science assignment. You also have your learning curves due by Friday, September 16th for chapter 8. Make sure there's nothing else. Your discussion board, your participation discussion board, make sure you're posting your first response by Wednesday, and you are posting your follow-up response to one classmate's post by Friday. And I'll be going through those. I've been going through and grading. I'm not really commenting on the chapter ones. I'm just going through and seeing if you did it, if you followed the instructions, you're getting your points. And I will try to have, we're a little bit away from our midpoint, right? We have about a month and a half left before like our mid-year or mid-semester. But I'm going to try and post around that time a sort of where you are in the class as far as your grade. So please be doing those participation things, which is doing your initial post, responding to someone else's, and watching the content, watching the lectures, because that's over 10% of your grade. But yes, please be checking Canvas. I'm going to be posting some announcements this week. I'm going to post when I'm going to be holding office hours this week and this weekend, so you can ask questions about your first assignment. Y'all have a great week, and I will see y'all in the next lecture.